Hi, welcome to Education with Eleanor. I'm Eleanor, that's me. Click subscribe and hit the notification bell for more videos on physics, mathematics and science. If you like this video, hit the thumbs up button. In this video, we are going to learn how to do the conservation of momentum, or how to calculate the conservation of momentum. Now remember, physics is a story, so when you're doing velocity, you need to assign direction to it because it's a vector quantity, not just a scalar quantity. A scalar quantity being only magnitude, or size. On top of that, if you have a vector quantity, you have a direction. So in physics, how do we tell this story? Or in maths, how do we tell this story? Well, generally, I like to assign the right direction, if it's going to the right, as positive, and the left direction as negative. So remember, there's a story going on, even in your maths side of things. Because physics is a story. That's what I'll always say. It's a beautiful story. The other thing that we're also going to cover a bit in this story is that you need to be able to speed read a question to get to the meat of the question. Now, I was doing a mini quiz, like this question's based on a mini quiz question that I did in class, and so that the students didn't get bored and they could have a laugh, I put a bit of a funny story into it. That funny story makes the first one or two sentences of the question, and the meat of the question is actually the last sentence. So we're going to talk a little bit about that in the video, and it's a really important exam strategy to understand, get to the point of the question. I hope you like my humour, and let's get into the meat of the video.
In this video, we are going to learn how to do a conservation of momentum question. So there are two ice skaters on the rink. Skater A, who is 80 kilograms with an initial velocity of 5.5 meters per second, is skating towards skater B, and they're not watching what they're doing, and they smash directly into skater B. Now let's define the direction that skater A is as positive, and I've just chosen the right just because I can. Now, skater B is coming from the opposite direction, and they are going at an initial speed of negative 0.5 meters per second because they are coming from the opposite direction. The two skaters are entangled in a twisted mass after the collision, so afterwards they're stuck together. That's what that means. And they will have a final velocity that is combined. So we want to know, what is the final velocity of these two skaters? Now, the mass of skater A is 80 kilograms, and the mass of skater B is 60 kilograms. Now, the law of conservation of momentum says that the initial momentum is equal to the final momentum, because in a system, if there are no external forces, then the total momentum of the system is conserved. So the initial momentum has to equal the final momentum. What we need to do is to calculate the initial momentum of skater A, and then we add the initial momentum of skater B. And that will equal the final momentum of the system. Now, with the final momentum of the system, this is also known as, you can do the final momentum of skater A plus the final momentum of skater B. To calculate the initial momentum of skater A, it's the mass of skater A multiplied by the initial velocity of skater A plus the mass of skater B multiplied by the initial velocity of skater B. That will equal the final final momentum of skater A. So that's mass of skater A multiplied by the final velocity of skater A plus the mass of skater B multiplied by the final velocity of skater B. Now this works when the objects, or the skaters, are apart after the collision. So they're two separate objects. But in this case, they are stuck together. So we have a combined mass, so mass A plus mass B, and their final velocity will be a combined velocity. The left-hand side will stay the same because they're apart at the start. Okay, so this is when the objects are stuck together. Now, because the objects are stuck together, this second version of the equation is what we will use. So let's substitute this information in. Skater A is 80 kilograms, and their initial velocity is positive of 5.5 meters per second. And then skater B is 60 kilograms, and they're going at negative 0.5 meters per second. And then the final is 80 kilograms for mass skater A plus 60 kilograms for skater B, and the final velocity is still v because we're going to solve for it. So on the left hand side we have 410 kilograms meters per second, and we're going to divide it by the 140 kilograms to get our final velocity. Our kilograms will cancel out to 1. Our final velocity will be, now we have, let's look at the significant figures. This one is one significant figure for the final velocity of B. The initial velocity is 4. Initial velocity of A is 2 significant figures. And according to our VCE physics rules, our masses, they're 2 significant figures. If you're doing the significant figures based on more general rules that are usually used in mathematics and in science, they would be 1 significant figure. But if it's been measured, then the 0 is actually still significant, and that's 2 significant figures. According to VCAR rules, if you have a whole number, the number of significant figures is the same as the number of digits. So because 80 is 1, 2 digits, it's 2 significant figures, and that's the same for mass B. So we need to round our answer to 2 significant figures. Now our answer was this very long number. I'll copy the first 4. It's 2.9285, and we have quite a few more. We only want 2 significant figures. So that's 1 significant figure for the 2, and then the 9 is the second significant figure. So after that, we don't want any more. Now this 2 here is less than 5, so we are going to keep the 9 the same. So our answer will be 2.9 meters per second, and because this is a positive answer, it is in the direction of skater A.
Thanks for watching, and I hope you found this interesting. This has been Education with Eleanor. Hit subscribe if you want to get more videos on physics, science and mathematics. Here are some more that you may want to watch. Hit the thumbs up button if you liked this video, and remember, physics is a story, and subscribe!